right, so we're going to get started with the webinar. So we're really happy to talk about are ESBs relevant in the age of microservices? So I'm just give you some context, give you some information. All these videos are going to be on YouTube, and they're also going to be on SlideShare. And if you have additional questions, you can ask them on the Apogee community. So I'll just get a quick introduction from myself. My name is Alan Ho. I lead our developer programs. And I'd like to introduce Nikhil.
Hey, thanks, Alan. It's great to be here. Hi, all. I'm Nikhil Hasija, co-founder and CEO of Azuqua. My background is in enterprise architecture, integration, product development, and product management. Glad to be talking about this topic.
All right. So why don't you take it away? Why don't we answer the question, are ESBs relevant in the age of microservices?
Thanks, Alan. I'll just get on to the slides here, let them catch up. So when we ask this question about ESBs and their relevance to microservices, I think we've got to go back to the origins, because every single technology that has come into play in the history of tech, ever since we've been creating them, has come into play with an intent. And that intent has been rooted in when it was necessary, why it was needed, what was happening at that point in time in the ecosystem. So let's start with where this thing comes from, right? So businesses bought software. Software didn't talk to each other. They bought integration software, and they spent gobs and gobs of money doing that. Now they created problems like software from different vendors. Hence, the need came in for master data management. After master data management, it evolved. You had integration brokers that came in, followed the hub and spoke pattern. EAI came into being, etc. Now, the industry also started to evolve. The integration world took hold, and it was around this whole strategy of we should obfuscate and try to create patterns that are rooted in governance and reuse and cost savings. So when the ESB model that came into play, it actually was answering the question, the call for trying to save cost and trying to get into use the current technology at that point in time. So ESB is a poster child for XML and SOAP, right? Inherently built for heavyweight architectures that scale over monolithically. So the essential need was most of these systems were actually sitting across multiple protocols. You had FTP, SFTP, et cetera, and all of those data, files, IDOCs, et cetera, need to be combined. Now, when you talk about these systems, they do not scream agility. These things are complex in itself, et cetera, and that's why banks and all use these type of systems. What is happening in the industry now that we see is that there is an obvious need for speed. The agility needs to be injected into the organization. So the real question that I want to tease out here is, can you get going fast? And the obvious answer, and the real thing that we're asking over here is, you can't go fast with ESBs because they were built not for speed and scale, but for orchestration and management of inherently non-scalable systems.
So Nikhil, why don't you just kind of like drill into that? Like, why are those systems? I mean, can you talk a little bit maybe about the standardization that occurred during that time, or kind of attempts at standardization? And by the way, audience, if you have any questions, please feel free to enter them into the Q&A window. We'll take time to answer those questions during the presentation, and we'll also leave the opportunity to answer. If we don't get to your questions immediately, we'll be answering them at the end. So Nikhil, can you just dive into a little bit more about kind of like the standardization efforts, UI efforts that were going on for that?
Sure. So let's go back to what I was talking about. Where ESB and the 90s tech essentially came from. Integration, the pattern was emerging. The second thing that happened was business process management. So BPM tools took care of control flow problems that integration actually left behind. And in order to differentiate themselves from integration, because it was largely felt like a solved problem back then, they completely did not address integration because they need to create differentiation. So you had a control flow problem where essentially people were building processes, and therefore if you look at BPMN, the business process markup notation, etc., you will see that it doesn't have semantics to actually handle data. And it was designed for control flow essentially. So you have people that can go ahead and enter, follow up on tasks, and really for people moving tasks where I'm turning around and saying, hey, you need to do these 5 things, and you'll come back to me into the system when you have completed those 5 things. And once you've done those 5 things, the process moves forward. So companies started to build connectors outbound into other systems. That need actually created the obvious need for automation around those business processes, and hence workflow was born. Workflow, and I'm talking Circa, Lotus Notes, SharePoint, and all those kind of things, and this trend has just been going on, and workflow systems maturing and coming into their own as well. So when workflow came about, workflow was addressing the problem of automation around task completion, specifically addressed to documents and systems of record on which it was sitting. Therefore, you see multiple systems actually have their own workflow automation built into them. Move forward, suddenly that's no longer relevant because most of your data is actually spread out on SaaS systems. And then what's happening in another way in the market is that speed and agility generally is required. So a business needs to be able to respond really, really fast. A business needs to be able to change its processes really, really fast. So gone are the days where you could spend 6 months on a project doing coding in ESB, etc. You need agility into the business. You need to be able to react fast because your competitors are reacting fast. Business requirements change in the time, half the time when these projects come out into play. So when we talk about the ESB or not ESB from that perspective, the pros are, yes, it has a connector orientation. There is a bus. It follows closely to the principles of service-oriented architecture, which are brilliant principles and cannot be argued with. But its implementation and the point in time of its implementation is the right question to be asking is that implementation inherently relevant today because we are faced with a world that is increasingly requires scale and increasingly requires speed. The cons there are message-oriented architecture. So you're in between these systems, you are often doing XML to XSLT translations. It does not scale. It does not process at speed. It is completely monolithic. And it is trying to fit into an architecture when we talk about the word microservices that are designed to be scalable. Actually, the obvious need for microservices is scale. Tiny, etc. How do you mix tiny with monolithic? You can't.
So what are the kind of people impacts of this, of not being able to do speed?
Sure. So, we've got developers. That's the #1 most constrained resource in the tech world today. And that is because, often we're using tech from 90s. And I don't want to say it in a tongue-in-cheek manner. It's actually very true. Because if we're solving today's problem with the tools that have been provided to us from yesterday, we are going to struggle, right? That's just the way the world works. There is too much to do on the developer side. The queue is really long. You have to be able to retire that work really, really fast. Can't deliver fast enough because of the tooling, because of how hard it is, and the scope of the problem is constantly increasing. Businesses buying, multiple systems that are in the cloud, and they're increasingly moving them into source of authority for the concerns that they're working on. There's not enough resources to support all the business needs because of the backlog, right? So there's a chicken and egg problem right there. And then every single time I've talked to a developer, and they say, hey, the business cannot make up their mind. The requirements change. And you can look at it from the flip of the coin side of things. When you talk to business, they're like, it takes too long, but my business needs change. So that's where tech teams are struggling, and really something needs to change.
So when you're talking about speed, right? Before we jump into microservices, Now, I think that, a lot of from a tech team perspective, they view the business like a monolithic team, right? And they get very frustrated when all these when the businesses can't actually consolidate their requests and give it to the technical team to implement. And I think the other way, on the other flip side, right, the business teams think that the tech teams are kind of a monolithic team as well. But in reality, tech teams are very distributed. So it's this kind of like misperception of how like business and IT really operates, because in the reality, like how people operate is actually they consist of it's more of a set of very, very small teams. So I think that's where like I guess talking a little now, kind of bringing into microservices. Give us your perspective on microservices and how this is why microservices then?
Sure. So I think first of all, to address your question, right, there is an impedance mismatch over here between business and tech, right? And that impedance mismatch is really around orientation. IT teams have been built from the time where essentially software was sold because of a report. Somebody wanted a report, and you put data into a system of record, and your IT team is responsible for connecting those systems of record and updates and all those kind of things. Now we are entering an event-driven business where signals are coming through really, really rapidly, and you have items that are changing really, really rapidly in the business landscape. So when we talk about architecture, business has already evolved. The reason business evolved is because revenue comes from there, right? So business is highly aligned with revenue, and their carrot and stick is both bonuses versus lack of employment. So it works really viscerally over on that side. So when you look at IT as a support function behind business, where business has adapted to this new world, and that's why you see them going out and buying SaaS applications, up the wazoo, it's because of that impedance mismatch. Now, how do we solve the impedance mismatch? When we move into the microservices world, we have an opportunity to actually take the core Uber principles of SOA, realign them with the newer world that we're seeing around speed and scale, and turn around and say, hey, developers, your orientation should be building microservices, and those microservices should inherently be built from the same principles of usage. So the one thing we would change is that rather than writing code, we would write code that is inherently written for consumption, and it is behind a business process or a business need. Now, when that happens, the impedance mismatch completely goes away, and then the engineer or developer has to think about scale and orientation. Those kind of things. So we break the microservices nirvana thing down into three things and three people. Let's just three different personas rather. There's a service layer which is built off the microservices, your data apps and all those things are over there. Then there's a consumption layer, and on that consumption layer you have things like automated workflows, processes that are triggering. There is mashed up applications. There are widgets that consume and show and notify. And then on the user layer, there is web, mobile, headless UI, just a notification on a mobile phone, those type of things. So that's how we're thinking about it.
And I'd like to also jump in, like kind of one of the very big like visual differences. You can almost think of it visually. In kind of the old school, the ESB land, it's very much hub and spoke. You have several services all talking to one bus. The bus is doing all the transformation and making sure that the bits get to the right service. But in kind of this microservices model, it's all point to point. It's really like a large mesh network of services talking to each other. And that kind of, every single service is responsible for communicating to the other service. There is no intermediary broker per se, right? So I think that's kind of a very interesting difference in communication, which actually mirrors the communication in a large enterprise. You don't have in a large enterprise, well, it's hard to tell. In a large enterprise, some companies, they file all communication through a project management or a program management team, and they tend not to scale very well. Whereas in a large organization that you allow open communication between the various teams, even though it seems messy because there's a lot of point-to-point connections within the organization, it actually gets the job done faster. So even though it looks more complicated, I think organizations can move faster by doing point-to-point, whether it's actually talking like kind of your corporate culture and your infrastructure and having that mirror in your architecture.
Sure. While I agree and see your point, I would change that point to point, which carries a little bit of baggage, Alan, to peer-to-peer. And those peers could be microservices, et cetera, that could inherently understand consumption rules of the other services, or you could have a consumer in the middle play that role for you. So yeah, sure, I see your point, and I think I agree with it.
So we have one question here, and the question was, does this model look more like point-to-point model that exists? Does the model more look like point-to-point model that existed before ESB? So I think what he's asking is, was there kind of like a point-to-point model that existed before ESBs, before even the creation of ESB, and why did they move to ESB if that was the case?
Okay, let's deconstruct that question. Point-to-point was bad because you had to reproduce code, and the concerns were changing. And the concerns were changing, and there was a lot of baggage associated with that point-to-point, because you write an API, you turn around and say, hey, I need another calculation. I'm going to go to the person who's published this interface, and I'm going to ask them to overload that interface for my use case. Well, that type of architecture is shunned upon today, right? When we talk the microservices world, you go tiny, scalable, those kind of things. So I think that question needs to be reframed in context to turn around and say, really, the point-to-point itself is not inherently bad. Is the consumption rules around the point-to-point or the peers in this matter, are they codified? Are they defined? And are the developers or the owners of these particular APIs or microservices have the discipline to not overload them into concerns that are not really relevant? So if I have a calculation service and I'm producing a calculation and someone comes to me and says, hey, you're giving me temperature in Celsius, I want it in Fahrenheit and I want it in Kelvin. Is it really my job to be producing that Kelvin, or should there be another microservice that does a temperature translation from whatever I send into that? I think those are the types of questions that we need to be asking. Is point-to-point inherently becomes bad when concerns get overloaded into those points?
Oh, okay. Yeah, okay. Makes sense.
Okay, so I think, yeah, sorry, go ahead, Al.
I don't know, I'm just going to ask, so why is this hard?
Right, I mean, leading question, right? The thing is, you've got data things that are actually simple, right? Now, why is this hard? Because you have people that are part of the process. You have devices that are part of the process. You have data that is really not inside your firewall as part of the process. The landscape has changed. The need is for speed and scale. The volume of data has changed. You have, I mean, classic simple use case that didn't exist about 10 years ago, even, that you have people talking about your organization on Twitter, and you need to be able to sentiment analyze what they're saying as best as you can, send it to a human to triage that to see if this is bad or good. Now, that sounds like a great process, but hey, let's become a company that gets 10,000 tweets, in an hour or 2 hours or whatever that volume may be. You suddenly can't do that process. Now you've got to put rules processors on play that say, okay, I will not care about one negative comment, but if people pile on to something and it becomes a runaway comment, that's when I'll care about it. Those type of scenarios come into play that are inherently not able to be handled by the systems of parts because they are contextless in this particular paradigm. So that's the area that we're looking at solving. There's asynchronous usage of microservices. You want to fire off your data and you want to forget about it, and you want somebody to just keep plugging away. You want to reach scale by using the assets that you have today, not the ones that you walked in with a decade ago.
And just for the audience that uses APIs, our audience, I hear a lot of times like, and even Apogee espouses this, is that, by having things broken down in microservices, you can create integrations very easily by creating like a lightweight node app that pulls together multiple microservices and displays it to the UI. And that would be in the bucket of what I call easy integration. Where integration gets hard is when actual people are involved. So if it's not good enough just to like call a bunch of synchronous services and return something, but you have to call a service which in turn calls an actual human being. And that human being has to take some action. Those kinds of integrations, even in the microservices world, requires like a very, very different kind of rethink of the tool set.
Right, they do. And therefore, when we look at microservices, there are some best practices that come about to say, hey, let's break this problem down into tiny atomic things so that we can actually scale them properly. Now, my previous example about the temperature calculation thing, if I'm being asked if I'm publishing data at the rate of 100 per second, 100 temperature units per second, and the microservice over there that needs to do the calculation between Celsius and Kelvin and starts to get 10,000, I can scale that out separately. I don't need to incur compute on my other microservice, which is only for my particular purpose. But the temperature unit conversion one would be for everything. Any service can actually call it. Any service could put it as part of their own orchestration or their workflow. The other thing that I would say is that the intent of microservices has to be very business aligned, because we have to think about usage first, not savings first. Because in the API economy, the thing that matters most is usage. If nobody's using it, it's as good as non-existent. But when you want usage, you want sufficient and complete APIs that users can actually access. The other thing that I would say is that microservices have to be inherently absorbed through the network. There is no local consumption of these microservices. So any developer that is building microservices has to take into account fault-tolerant scenarios like network throughput, network up and down. How does your service scale? It has to be stateless because if there's a database attached to it, it does not qualify the rules of microservices, then you cannot horizontally scale it anymore because you're going to have to scale. Now, this is not like a hard and fast thing that you must make stateless microservices. True, that's the pure pattern. You will need to somehow maintain lookups somewhere, and you have to think about what the scale limitations of your lookups are going to be. Does that lookups store need to be shared or not? Those are the concerns that come into play. Generally follow a request-response pattern, right? The entire microservices paradigm, I mean, this is another difference from ESB, is that all of the APIs, microservices, are generally following a REST-based, RESTful architecture. So on the protocol level basis, things are very simple. I mean, you mentioned you can throw up a node server and start absorbing this. It gets complicated when you want to do 2 or 3 things and combine them together. So generally, it is fundamentally easier to actually absorb these microservices. You just have to keep in mind that, hey, people might want to absorb it for high speed using a WebSocket, using AMQP, or other types of protocols that are more modern, more connection oriented. Actually, I wouldn't say AMQP is modern, but WebSockets definitely. And then expose a consumption blueprint so that people who are absorbing your microservices can actually know how to integrate on those microservices. And sometimes this is done through a catalog of services. Sometimes a developer can just publish on APIs is done via Swagger docs. So I would say think about publishing your consumption blueprints of those microservices.
Cool. Well, it seems like, so you've created all these microservices, and now you have to have the tools to actually integrate these microservices. Well, why don't you kind of like show us, the new things especially that what new tools can developers actually use?
Sure. I've been waiting for this for the last 30 minutes. Thank you, Alan. Hey, so Azuqua essentially is a consumption platform for APIs, microservices, processes to power a real-time digital agile enterprise. I mean, when we talk about the microservices orientation, we break it down, developers are creating these things, and for business to become agile and for engineers, for IT tech teams to be able to retire their quota, reduce their queue, they have to empower the business to be able to take action on their behalf with anointed microservices and the rules of accessing them. Azuqua makes that available through a visual, fast interface that injects agility into your organization. So we're used by household names such as Dun & Bradstreet. The Excel add-in for Dun & Bradstreet runs on top of Azuqua. We make those services available. We handle all of the billing and management, and it's all done through flows, not a single line of code to make that happen. Azuqua is the default platform for workflow management in GE's Predicts, and it's used for certification of engines, for alarming scenarios where assets are going through and attenuating, sending lots of data, signals need to be extracted, those kind of things. For Charles Schwab, we are part of the marketing pipeline where when any document that gets published by Charles Schwab happens to flow through Azuqua, and we orchestrate movement between different people, actions by people, triaging, and movement of data through multiple systems.
Well, I think people are like itching itching right now. So, do you mind if you can? We're going to show a demo. We're going to show things with Azuqua, and we're going to show also the Apigee integration.
Sure.
Take it away.
Let me get started with. Thanks. Let me get started with that. And boom. When I have successive mirroring, okay. All right, so this is Azuqua. I hope you can see it. We use Azuqua for all sorts of things. We use it for automating our systems. I'm showing you the DevOps organization where the CI/CD pipeline of Azuqua runs on that. So we use Azuqua for doing continuous deployment of code in our systems as well. We use Azuqua to monitor Azuqua as well from the outside. So there's a little bit of turtle on top of turtle scenario going on here. And then essentially you create flows, and flows are processes, workflows that orchestrate people, application, APIs, microservices together in a unified manner and get attenuated by events of interest. So let's go ahead and just to introduce people to the vernacular, get started on creating a new flow. I have a list of channels over here. We have an extensive library of channels or connectors, and we add these on customer requests as well. So I'm interested in, let's say, going out and monitoring a system. So my Salesforce system per se. And what I want to do is I want to hit monitor. I can monitor for new or changed records. I can only look at records that have changed. I can monitor for new records or updated fields, etc. So I monitor my records. I can hit a new account over here, enter my name. This is Nikhil. Choose sandbox or production, authorize, and I'm going to get an OAuth page where I can just log in. And I hope I remember my password well. Boom. So we've authorized, and now I'm looking at all the objects that I have access to. I can choose account in this case and go forth, and I'll get the fields that I have access to, and then I can do something. So that's an event of interest. I'm monitoring when a new account gets created. Now what can I do with it? I can do all sorts of actions. I can actually go ahead and put it in Slack. So that's another type of connector we have. I can send a message to Slack. I've already authorized it, so it's looking at my channels. I can send this information to a sales channel, choose if I want to send a bot or not, and then just basically send the name over. And it's a simple vernacular of mapping these things through. We have many connectors, and we also have the Apigee connector. And Alan, I'm going to send this back to you because you built some interesting flows with the Apigee channel. So why don't I give it back to you to show what you're doing with it?
All right. Give me 1 second here. I want to give some context. So just saying a little bit of context. If you're building an API and you want, one of the really fun things about Azuqua, and I say fun, because you spend a lot of time building your APIs, and now you need to connect those APIs to other popular systems, whether it be like Salesforce, etc. So one of the reasons why we're pretty excited about Zuko is because I actually used it to solve my own problem, which was at Apigee, whenever any new accounts gets created, I want to be able to store it actually within the Apigee system itself. There's a system called a backend as a service, and I just needed a quick way to load the data from Salesforce into this backend as a service. And by afterwards load into the backend as a service, we could use the data for doing personalization. We can use the data for doing, personalizing the actual Apogee website, personalizing the developer experience. So let me just kind of show you quickly what that looks like. Is the screen up? Okay, great. So what I did was I added the Salesforce channel, and I selected leads. So these are all the leads that are coming in. So whenever any new lead gets created, what it's doing is that it's calling this Apogee API. And it's actually fairly easy to do. You do a drag and drop, and you can basically select your verb. You select your environment, and then the product is integrated, and it basically pulls the list of APIs that you've created within Apigee. And so that's very, very, very convenient because it basically allows your business, you as a developer spend all the time creating the APIs. It allows the business to go create the actual integration themselves and not have to bug you. You create the APIs and the business has some half-baked idea that they want to implement. You can kind of implement it on the fly with them and then show the actual business user how to do it. So, once you press run, the other cool thing that I saw in this was that there's also a lot. You can see how many. You can see all the data, and you can see all the errors. You can see all the errors, and it has the ability to retry. Things go wrong. We're talking about people, right, involved here. But it allows a pretty easy API call. Yes, for example, over here, I could probably, okay, not that one. But it gives you kind of information on where things actually gone wrong. So inside my back end, I have a list of all the users, all the new signups for Apigee, and I can do something like and this is actually myself, and it's showing my Salesforce data saved into Apigee, into the backend as a service. Right. All right. So that kind of shows how the products are integrated. I think there's actually some questions here, actually. We'll have some time for questions here. So I have a question here. How do you see message brokers such as Kafka fitting into this diagram, into this paradigm, Nikhil? Okay.
So for high-speed ingest scenarios, Kafka is actually great. I'm slightly familiar with their protocol, but I think when you're looking at high-speed ingest scenarios, you want to do things like streaming analytics, etc. At that point in time, these things become interesting. The thing that I wouldn't use it for is disposition of the events that come out of the event stream. So let's say you've got, go back to that temperature thing. You've got lots and lots of temperature things that are coming through, and you want to implement some sort of streaming analytic on it and say, if the temperature and you can use Spark, not Spark, sorry, Storm also in the same ilk. You want to implement a streaming analytic to say if the temperature is over 50 degrees for 5 minutes or so, then go fire this rule. And then the question is what happens to the rule. We look at Azuqua being, and I'm talking strictly in context of Azuqua at this point in time. We look at Azuqua fitting into that as the rule, the disposer of that particular event. You could do that with Azuqua as well. I would say that for simple rule processing like that, Kafka or Spark Storm would work better. I hope that answers the question. If it doesn't, please, go back on Q&A and clarify just a little bit. Happy to add more color.
Okay, and we have another question, which is, how do you see OData becoming more of a standard, blending the world of ESBs and REST? I also have some thoughts on this too, but I'd like to hear what you think.
I think there are formats, and then, I'm going to say something controversial that I know I'm going to get roasted on. So here's the thing. There is data formats, there is protocols, and then there is forced implementations of those protocols. I really don't know if another mechanism of accessing data needs to exist on top. And I know I'm going to get roasted on this from the OData community, but really, I'm not sure if a data presentation disposition format actually can drive the industry. It could be a part of a small problem that gets solved, but I don't think it's a driver. So Alan, your thoughts?
I think OData is dead on arrival. The reality of the matter is, the services, first OData, in some ways people think of OData as a lightweight interface on top of SQL. Not only is it lightweight, but actually it's just anemic. It doesn't allow you to do things, okay, maybe they have updated the standards that nobody actually adopted, but like the original versions of OData didn't allow you to do things like group by or any kind of like powerful query that you would actually really need to do in a workflow. So I personally think that OData is not necessary. REST on the other hand, is a protocol that you can actually do a lot of things. You can be very expressive in your actions, and you can actually put a lot of the logic that you would need, the kind of like the logic that you need behind the microservice itself. So that's kind of my thoughts on OData. All right, Tarik, so we also have another question, which is, how would you apply business rules in orchestration?
Sure. So inside, what we didn't get to show you is we have a full logic iteration capabilities inside Azuqua. So you can work on collections. You can actually do if and else type scenarios, branching. Parallelism is inherently built into the product because you have the flow decomposes to a graph and the engine auto balances which things can run asynchronously, which don't have input, and it essentially aligns all of that stuff on its own. So a developer doesn't have to think about those items. They just get to lay out their process, and the engine optimizes things that need to happen asynchronously, synchronously, which need to wait versus which can be completed and be sitting out there.
And for me playing with the tool as well, if a business rule is relatively easy, that can be kind of like described via if and else paradigm, which is actually a lot of scenarios. Then it works. Using Zuko directly, it works great. But if you have a much more complex business rule, in the microservices paradigm, what you should do is you should take the very complex business rule, put it behind a microservice, and let your integration, you let something like Azuqua be able to call that microservice and execute those business rules. Okay, so then the next question was, how does Azuqua compare to Zapier? And I think I personally have a question like that as well, Zapier or IFTTT.
Well, so Zapier, IFTTT is in the consumer land, and Zapier is an SMB tool. Azuqua is strictly meant for enterprises.
And what does that mean from a feature perspective, or what does that mean from a feature perspective, or like what kind of users would use Azuqua more than IFTT or Zapier?
Sure. So let's take when you have complex orchestrations across multiple systems, people, you have wait states, you want to wait your workflows, you want to be able to wait for other events to occur, and you want to merge data, marshal it, apply contextual rules, look up in different systems, merge with files and things like that. You have those are just on the flow level featured. You have iterations, like you have a collection and you want to do a map reduce function on it. Good luck doing that in any SMB tool. So those are just on the feature level of the flow. Then comes the surrounding parts. When security is important, when reliability is important, when you want to be able to inject your own keys and encrypt the data using your own keys that flows through the web, those type of security issues, when you want to integrate with your SSO, those are some of the enterprise features. When you want to look at impact analysis on what this change would actually do for you if you made this change, and what is the traceability matrix of this thing, how many times my execution has fired back-off rules across multiple APIs, order of operations, exactly once, only once type commits. Those are the things that an enterprise cares about, because those are the things that business cares about. You don't want stuff to be created twice, etc. So those are the things that we have out of the box for enterprise.
Okay, cool.
And speed.
Okay. Awesome. Well, the next question I have is, can you use or integrate custom components? I guess basically custom services.
Yes, you can. You can. We have a developer experience that we are working with close partners, and we will bring that out, or close customers and partners. We'll bring that out shortly. But you can also call any RESTful endpoint. If it is exposed as a microservice, you can call it as an endpoint. You can define your own headers, keys, etc. Send that over to the microservice, so you can orchestrate systems that are elsewhere. If these are systems that are generally key-based or behind basic OS, you don't even need to build a specific connector. You could just use the action by defining that within a part of your flow. So I hope that answers your question.
Yeah, and I'll add to that. That's actually one of the reasons why Azuqua and Apigee partnered to create the connector, the Apogee Connector, so that when you basically our recommendation is, if you have a system, a backend system that you want to connect with Azuqua, first put an API in front of it. Put a RESTful API, have it exposed through the Apogee Edge, and automatically all those APIs will show up within Azuqua, and all the security concerns, auth concerns are all kind of taken care of. So a lot of the the baggage, kind of the security issues that the team, the security team might have, especially when you're letting business users call APIs, is kind of taken care of. All right, so we have one other question, which is it JavaScript based?
There's a core set of technologies that is used in, I'm assuming this is a question of how Azuqua is built, because the front end has a lot of JavaScript. There's a core set of technologies that we use in Azuqua. We use a combination of tech. We have JavaScript for all of our I/O functions, Node.js, etc. And we use that mostly for I/O bound operations that don't impact the CPU cycle. We write code that is going to impact the CPU cycle basically in C. And so a lot of the crypto functions, KMS handling functions, all of the encryption features, etc., are written in C, because Node just doesn't scale over there. For things that require thread safety, concurrency, and really reliability, they are written in Erlang. And in addition to that, the rules processor, we have a DSL that is actually built on top of Python. So we use the right appropriate tool that gives us the ability to actually use the language to its fullest extent and things that come with it, or the real reason of why that was built.
It sounds like you really adopted the microservices paradigm with this product whole hog, right?
Well, yeah, so Azuqua is actually a set of microservices. When it gets deployed, it is a set of microservices that work together. So the encryption microservice gets the data from every single call, and its job in life is to encrypt and decrypt, and that's all it does. It doesn't know what the keys are, nothing. It calls the key gen microservice that gives it the keys for a particular customer. So all of that stuff is a complete set of microservices that work together.
And when you release the SDK, what would the developer? I think this is from the same person who asked about integrating custom components. When you add extensibility, would it be like JavaScript, or how would that be handled in the future?
Sure. I mean, our approach, and this is a strive for perfection. I would say our approach is to not have to write any code. Now, that's not always possible. So I'll explain a little deeper what that means is the engine that we have written works on a set of primitives. Every single flow compiles down to a graph on a set of those primitives. So you have, and this is essentially the question between, SMB versus enterprise and all those kind of things. The engine pathways have been exercised, the code pathways have been exercised billions and billions of times, and they're exactly the same. Every single flow decomposes to a document. That document has a schema specification of what it needs to do. The connector that you're looking at, the Salesforce connector, composes to a document in a similar way, which breaks down into AND and NOR gates all the way at the graph level. So the engine just executes those set of primitives. And it's taken us many years to write that engine, but we think it's a major step in reliability and giving the ability to linearly scale. So Azuqua linearly scales. We have deployment models that are on-premises, private cloud, and the public cloud as well. So one will linearly scale. So when the developer tool is announced, we will have the ability to create connectors. We will have the ability for users to be able to project their own code. The only thing that needs to be thought about is the sandboxing of those components, et cetera. Now you can put your code in Lambda or CloudScript, et cetera, to call that also if you want to write really, really tiny code. But the orientation that we have in the company and when we think about is how can we make something completely code-free where an engineer or a developer is really concerned about the business value that they want to bring in and write the tiny microservice and leave the entire orchestration and consumption for the business users to us.
So we have another question coming in. How is throttling accomplished?
Too deep to go in over here. And I mean, on our API, we have throttling built in. So if you're calling these flows from an external event, they are going to be throttled based on your plan. We take care of that. Now, if you have external systems that implement throttling, at the design time, we look at what those throttling criteria are and essentially back these requests through queues so that the completion is more or less, don't want to use the word guaranteed.
Yeah, and just to talk through that, if you're exposing your API, so the kind of maybe the big concern that people have when they expose their APIs is to businesses is that businesses will create these workflows and then pound their system really hard. Well, in Apogee, so when you actually create your APIs using Apogee, you would set the various users to have throttling limits and quotas so that they won't overload your back-end system. So that's fairly easy to do and to make sure that your custom system is not overloaded. Okay, we probably have time for just one more question, which is what are request/response SLAs? And maybe I'll just add to that, what kind of visibility tools do you have towards SLAs as well?
Yeah, so I'll break that question down into a few different vectors because when we look at service level availability and agreements, we think about what we make available to our customers. And I think the insertion of request response in here makes me believe that the question is how many seconds does it take for a particular flow to complete, or for Azuqua to be able to answer the question. I don't want to throw any numbers over there because these things are inherently built on public networks, and you just can't. But within the engine, most of these workflows, after their each instance of these are completing anywhere from 200 to 300 milliseconds, depending on 5 steps. That's what we've done within there are 5 steps. They take anywhere from 200 to 300 milliseconds to complete. Add network latency to it, and you have your request response, data, and really depends on where that data is coming through. We see things going with Salesforce and Slack very rapidly. Other systems, have spin up, tear down, things that happen differently. They take a lot more time. I'm hoping I took it in the right vector that you wanted me to. If you do have more questions, our emails are at the end. Feel free to reach out.
So we're just about out of time for the presentation. Thank you for all your questions. If you have more questions, you can connect with Azuqua directly. And before I close, I also just want to mention they do have a white paper. Before I close, I just want to invite everybody to the Adapt or Die tour. We're going to be having great speakers at several conferences, several locations around the world. And, it's going to be a lot of fun for, it's going to be a little different. It's going to be smaller conferences, much more personal conversations, and you can share your API best practices with everybody else. All right, thank you very much.
Thank you.